Hey everyone, so today we are going to be talking about something that is stemming off of this age of exploration known as the scientific revolution, right? And 99.99999% of the things that you learn, not only in science, but also the ways in which we tackle knowledge, really does stem in a lot of ways from this scientific revolution that we're going to talk about today. So the scientific revolution was a period in Europe from 1543 to 1687 in which there were a lot of advances in mathematics, astronomy, physics, biology, and so many others that ended up coming later in other related thinking eras. And really for Europe, this was a separation from the church in a lot of ways, who was the arbiter of knowledge, the one that would give out knowledge and tell people how to think in so many ways. So, in thinking about the scientific revolution, there's a few different ideas that became major causes for this revolution. The first one was something we talked about in our last unit of the Renaissance and Reformation in terms of the Renaissance humanism. And this idea, again, that human thoughts came from human beings and human sources rather than divine inspiration, rather than just from God, really led people to say, well, if I can come up with things, if I can create things, and if I can create ideas, what else could I discover? The other one, though, is something that came from ancient Greece in the times of Socrates and Plato and Aristotle in terms of looking at Greek rationalism, and that's individual thinking. And so people under this thing are applying logic and reason rather than just faith to explain how life worked rather than the church. Another couple things that ended up being huge drivers in terms of the scientific revolution comes from what we've learned about just this unit, and that's the European age of exploration. And this motivation to continue finding new routes to other places in the world and the drive for larger economies and more land ended up having significance in terms of these areas of math and science in order to find these places. And it was really a driver for much of this. Um, and in addition to this age of exploration, coming into contact with other cultures where you are learning more about things like Muslim science and you know ways in which the Middle East was far more advanced in terms of mathematics and navigation arts at this time. Um, and then also the trade routes themselves allowing ideas to spread helped in terms of these thinkers in Europe now being exposed to different perspectives and frames of mind. And that's, I mean, even if you think about yourself, being exposed to other people's is such a boon uh, for our own learning, for our own knowledge, for, piecing together things that maybe we had faced obstacles upon, especially in terms of knowledge or skills. And so all three of these things really had a major impact on the development of this scientific revolution. Another major thing, though, to come out of the scientific revolution, and really one of the central things that we still obviously use to this day, was the widespread adoption of the scientific method. And all of you know the scientific method from your learning in school. But this was really something where there is now a method of research in terms of finding more out about the sciences, whether they be human sciences later on, but physical sciences as well. How does the world actually work? And so by making an observation, by asking a question, by forming hypotheses and forming predictions, by then, making and testing that prediction and finding out those results and, evaluating how the results came about, finding conclusions, making connections, all of these things tied to the scientific method really, helped in terms of spreading scientific knowledge throughout this scientific revolution, but also beyond that. And so, really, over the course of the last few slides, we've sort of seen some of the importance of the scientific revolution. For one, you had the formulation of the scientific method as just announced. And then also, because of that, you have an expansion of scientific knowledge. You also have an emphasis on reason and, a system of observing nature, both in terms of like physical nature, like birds and plants and gravity and the earth and all of these different things. And then also in terms of how humans operate together. But the last major one was that a lot of times it would disprove church explanations of scientific events, right? And so we start to have a greater widespread belief. This idea was around longer than that, but you start to see more people accept it because it came from science and had been sort of proven in a lot of ways. Um, Things like the fact that the earth is round and not flat. And so all of these things, in addition to what we're going to be talking about over the next several slides, were so important to this scientific revolution and why it is significant even to this day. Now, a few people that were major figures within the scientific revolution. One was Nicolaus Copernicus. He developed the heliocentric theory, in which the sun centered the universe. Before this, a lot of religious scholars said that the Earth was the center of the universe. And so now we see that the sun was the center of at least our galaxy. Here we see two models of the difference between the geocentric and the heliocentric method. But then we have Johannes Kepler, okay? And not only did he say that instead of a perfectly circular planetary motion around the sun, that instead we have more of an elliptical planetary motion, and that's uh, part of the reason that we have seasons on Earth, as well as the tilt of the sun and the tilt of the Earth, uh, all of those sorts of things. But Johannes Kepler, very, very important in those ways. And then we have Galileo Galilei, okay, usually just called Galileo. But he used the telescope to support the heliocentric theory. So backing up what Copernicus said about the sun being the center of the universe. Now he's not only important because of this, but also he really created and helped pioneer the scientific method that was so important. Now another important thing to remember about Galileo is that his ideas were not uh, seen as good in the eyes of the Catholic Church. And in fact, at first, they, highly viewed them as blasphemy, and they tried to kick Galileo out of the church and tried to really oppress him for his viewpoints. But luckily, as time wore on, more and more people accepted it, um, and so Galileo was let off the hook in those ways. Another one, obviously a major figure, is Sir Isaac Newton. And this was an Englishman who developed the law of gravity and the laws of gravity. Obviously, being able to have 2 feet on the ground, his knowledge allowed us to really understand so many other things so much more, like the idea of calculus. Um, and so Isaac Newton was a huge figure in terms of our own knowledge. And then the last one we're going to talk about here in terms of physical biology was the Englishman William Harvey, who discovered the circulation of blood in the body through things like veins, and how the blood sort of goes throughout the body. So with all of those being said, The scientific revolution was extremely important in terms of our own understanding of the world and continues to impact us to this day. Just another way of looking at discovery during this period of time in the 1500s and 1600s, starting with the Renaissance in the late 1300s, but going all the way through the Age of Exploration and with this scientific revolution. All right, as always, if you have any questions, please let me know, and I hope you all have a great day.